All right, so we're going to talk about 1.5 measuring and constructing angles. Again, before Friday, you should already have your vocab words done. There's a total of 12 words. And then in class at the very beginning, we'll be doing the self-assessments from, again, 1.5. So again, you should be watching this video ahead of time, getting your index cards done, and then you'll be ready for class. Now, as far as this section goes, there is a lot of ideas that are things that you may have talked about in the past. So you'll notice there is a lot of vocab. Angle, vertex, size of angles, interior of an angle, exterior angle, measure an angle, acute angle, right angle, obtuse angle, straight angle, congruent angles, and angle bisector. Majority of those words you've actually seen before. The only two at the very end, congruent angle and angle bisector, are probably the ones that are newer to you. The rest of them are things that you should have seen in previous math classes. So some of this might seem a little repetitive, but again, we're going to go through and at least get the basics of this lesson down before class on Friday. So, an angle is a set of points consisting of two different rays that have the same endpoints called the vertex. The rays are the sides of the angle. So in that diagram off to the side, you can see angle CAB or angle BAC. Angle at point A, that is our vertex. And then you have the two rays, ray AC and ray AB. Now, you can name an angle a couple of different ways. So you have the angle symbol that you need to be familiar with. And you can name an angle based solely on the vertex. So since A is at the vertex, that would be angle A. Or we can use 3 points. If we use 3 points to name it, we're using 1 point from each ray, the vertex. And when you do this, you have to go in the order of having one from one ray, then the vertex, and then one from the other ray. So the vertex will always be the middle when using 3 points. So that angle again can be either angle BAC or angle ACB. So sorry, I said that wrong. Angle CAB. So again, you have 3 options there using the letters, but then you also have one more option if you have a number in the angle, like the one that's right in there, and it doesn't have any type of degree on it or any type of measure associated with it, then that number can also be used. So this could be considered angle 1. All right, now for every angle, there's also an interior and exterior. So all of the points that are between the two rays are the interior. All the points on the outside of the two rays are considered the exterior of the angle. All right, the first example. So we have a lighthouse keeper measures the angles formed by a lighthouse at point M and 3 boats. Name 3 angles shown in the diagram. So on this diagram, you can make a total of 3 different angles. Now, there's more than one way to name each angle, but you do have to be careful because all 3 angles that we could name have a vertex at point M. So let's go back for a second. We said that we could use on that angle, angle A, our vertex A, as our only letter when we say angle A, and that's fine. But on this one, we cannot use only M, because if we said angle M, we wouldn't know which angle we were talking about. So there are 3 different angles coming off that same vertex. So first, we have that top angle, which can be either angle JMK or angle KMJ. All right. Then we have the bottom angle there. That bottom angle, again, can go in either order, KML or LMK. And finally, we have the bigger angle made up of the 2 smaller ones, angle JML and angle LMJ. Now, each of those could be named 2 different ways. We used 1 point from a ray, then we used the vertex, and then we used a point from the other ray. There's no other way to name this one because M is the same vertex for multiple angles. So you can't use it naming, you can't use it just the one letter to name it. And we don't have any numbers on here, so we can't use numbers to name it. So those are the only acceptable options right now. Now, measuring an angle, We use a protractor. So just like we had the ruler postulate from the previous section, we now also have the protractor postulate. So in order to measure an angle, you have first the angle shown there. You have the little opening of the angle, point O, which is our vertex, goes on the little dot that's on the protractor. Then you line up one side of the angle normally with one of your two rays. So they have ray OB lined up with the 0 line on the right side of the protractor. We could have also done it the opposite way and lined up OA with the other line on the left side of the protractor. Now, depending on where you start, you're going to have two different sets of numbers. You have numbers that start from 0 going from left to right, and you have numbers that start from 0 going from right to left. Since the ray that's on 0 is the one to the right side, we're starting from 0 from the right and going around to the left. So if we're measuring this angle, we'd start at 0, we go around, following that same set of numbers. This is open to 140 degrees. So that would be the measure of that angle. It's 140 degrees. Now, there are 4 different ways to classify angles based on their measures: acute, right, obtuse, and straight. All of these you've probably heard before. Acute angles are angles that are greater than 0 but less than 90. Right angles are exactly 90. Obtuse, greater than 90 but less than 180. And then straight angle, exactly 180. So now, if we wanted to measure the angles that are here, we don't have to line it up with 0. Just like on our ruler postulate, in our protractor postulate, we could just subtract to find the difference. So looking at the diagram, we have angle GHK. So GHK, that's the one now highlighted in red. You have the first side lined up with 0 to the left, which is the outside ring. And then it goes around to 125 degrees on that outside ring when you get to ray HK. So this angle is 125 degrees. If you had used the inside ring of the protractor, it is possible to still use that. You have one side is at 180, one side would be at 55 if you use the inside ring. If you subtract them, you also find that 180 minus 55 gives you 125. So in either case, the measure of GHK is 125. Now notice, they put that M in front of the angle. When we write what the measure of an angle is equal to, you have the angle symbol still. You still have what it's called, but then in front you put the measure. So M stands for measure. Now, what type of angle is this? Since it's greater than 90 degrees but less than 180, it's an obtuse angle. Now, the next one, angle JHL. So we can use the other side, which is at 0. And then LHL points straight up at 90. So on here, we have a right angle, which passes through 90. Again, if you have an angle that's exactly 90, that's a right angle. The last one, LHK. Now this one, a little bit tricky. There's LH. Here's HK. Neither one goes through 0, but again, we can subtract. So whatever ring you use, whether it's the inside or the outside ring, just make sure you look at both numbers from the same ring. Now, the one's at 90, so no matter what, we have 90, but we're going to subtract that either from the bigger number or subtract the smaller number from that one. So we could either do, let's see, that's one, it might be slightly off, but we got 55 roughly, or 125. So we have either 90 minus 55 or 125 minus 90. Both would give us the same value of 35 degrees. Again, it's always a positive value, just like when we're doing distance. And again, that last one, since it is 35 degrees, is an acute angle. All right, on the next one. So now, identify congruent angles. If you look at the diagram, we have a couple different things marked with these red arcs. those arcs are a way of saying congruent when dealing with angles. So just like we had the tick marks on our segments, when we're dealing with angles, we have arcs. So two arcs are congruent when they have the same measure. Identify congruent arcs labeled in the built design. So on here, we can see that G has one arc and B has one arc. So G and B must be congruent. Also, D has two arcs and F has two arcs. So D and F must be congruent. And then finally, sorry, I didn't show the answers there. So again, we had our two angles marked with the 1. So those two are congruent. The two angles marked with the 2, those are congruent. For part B, measure of angle ADC is 140. So ADC. So since ADC is 140, and we said that ADC is congruent to EFG, then we can solve for EFG because it's the same measure. Again, congruent angles have equal measures. So that is also 140. All right, using angle addition. So just like we had segment addition, now we have angle addition. When you have two angles that are next to each other and share a common ray, you can add up their angle measures to get the measure of the overall angle. So on this one, we have RSP and PST. If we add those two together, then we get RST. Now, on this example, given that the measure of LKN is 145, find the measure of LKM and measure of MKN. So now for this one, we were told that LKN, so that's the entire angle, is 145. So we're going to write ourselves an equation. We have the two smaller angles add together, gives us the big angle. We know that that big angle is 145. And then we know that the smaller angles can be represented with those expressions of 2x plus 10 and 4x minus 3. Now, just like before with our segment addition, with angle addition, we are now solving. Once you have the equation set up, which is one of the harder parts, then we can go through the process of solving using some algebra. So we had our values plugged in. Now we can combine like terms. 2x and 4x gives us 6x. 10 and -3 gives us 7. We can bring the 7 over by subtracting it, and then we can divide by 6. So x is 23. Again, double check and see that you answered the question that was being asked. So it said, given that the one angle is 145, find the measure of, and it wants us to find the measure of two other angles. So of LKM and of MKN. So there's two smaller measurements. So now we're going to take that x value and we got to plug it back in. So 23 goes in for x in both equations. So 2 times x, which will now be 23, plus 10. 2 times 23 plus 10 is 56. Then we have measure of angle MKN. So if we take that and plug in x of 23, 23 times 4 minus 3 gives us 89. Now, if you want to double check to make sure that our work is correct, you can take those two values, since those are two smaller angles, they should add up to the same thing as the big one. So does 56 and 89, do they add up to 145? Yes, they do. So we did it correct. All right, bisecting angle. Just like we had segment bisectors, we have angle bisectors. An angle bisector is a ray that divides an angle into two congruent angles. So on here we have XYW and ZYW. Those two are going to be congruent angles. Now, we can also construct an angle bisector and also construct angles. So we're going to take a look at that in class as well, using a compass and a straight edge. But first, example 5, using a bisector to find angle measures. So QS bisects angle PQR, and measure of angle PQS equals 24. Find the measure of PQR. Well, first thing, we don't have a diagram, so draw one. You always want to draw a picture if you're not given one. So on this one, draw a diagram. So we draw the diagram. We have angle PQR. We draw in QS as a bisector. So we now have those two pieces are congruent. We have PQS. We can label as 24. So now we can see this. They want us to find PQR, which is that entire big angle. So that one is 24. The other side also has to be 24. So those two are going to be equal. So RQS also has to be 24. And once we know that piece is also 24, those two together will give us the entire angle. So 24 plus 24 gives us 48. All right, so constructions. All right, I'm just going to show the steps. We'll look at this again in class, but we're going to use a compass and straightedge to construct an angle that has the same measure as another angle. So on here, first, we can draw any angle we want to copy. All right, but we're going to copy this angle first by drawing another line segment, which will be our first ray. Then from one point on there, we're going to call it an endpoint, which will actually act as our vertice in this drawing. We're going to take our compass. We're going to place it on A in the first drawing and swing an arc out in front. So that goes through the interior of the angle. Then we repeat that same measurement arc on point D. So repeat, exact same, didn't change anything on the compass. Once we do that, now we are going to change the compass so that it's open to the width of that arc that intersects the two rays. So we're going to put our compass on our figure. Oh, I may have missed it. No, it just didn't show it. So there's one thing missing there. From C to B, that's how we're getting the measurement in order to open our compass. And I'll show it again tomorrow in class. But we open up the compass using C and B, and then mark that distance off to find point F. And that would be our construction. Oh, and then point F, of course, we have to draw our ray finally. Sorry, draw our ray so that we have the same angle. So now we have angle FDE. All right, the other construction is an angle bisector, very similar to what we just did. We're going to first start by drawing an arc between the two sides. Now, we don't have to do a second drawing. We don't have to copy an angle, so we're just bisecting it. So from the point, we draw an arc, so that goes through both rays. Then, from those 2 points of intersection where the arc's hitting the two rays, we move our compass to one of those 2 points. Make sure that the compass is at least more than halfway between C and B. And then once you know it's more than halfway, we're going to swing an arc out in front from C. And then we do the exact same thing from B, not changing the setting, using that same setting, so that that point is equal distance away from C and B. And any point equal distance away from those sides is then going to fall on the bisector. So we draw another line going from A through that intersection. We're going to call it G. And we have ourselves an angle bisector. All right, that is it for this video. Again, those are all the basics. So again, for class tomorrow, you should already have your vocab done. And then we will be doing the self-assessment at the start of class. So if you want to get a head start on it, you're more than welcome to.